Greetings, this is Sri Ramalu. Now I'm going to explain the aliasing in the digital images. So these are the contents I am going to explain in this presentation. First of all, we see the sampling theorem in the one-dimensional signals. After that, the two-dimensional sampling theorem. Similarly, whatever the concepts we studied in the one-dimensional sampling theorem. Similarly, same kind of mathematical analysis and all we see in the two-dimensional sampling theorem also. After that, how these aliasing effects will going to be affect the images, and then what are the remedies we are going to see in anti-aliasing effect, anti-aliasing uh, techniques. After that, some other references I'm going to use for preparing this presentation. First of all, we are coming to the sampling theorem. We are already know sampling theorem is applied for the only for the band limited signals. That means in the given range of frequencies only the signal spectrum exists. Other than that, the spectrum became zero. Only that type of signals we may see in the sampling theorem. So whatever the sampling frequency we are selected, that must be greater than that the twice of the highest frequency of the given band limited signal. So we see the condition that fs, where the sampling frequency greater than or equal to the two times of maximum frequency present in the given signal. So this is what the sampling theorem tells us. So this is the statement of the sampling theorem. After that, we see some of the spectrums we are looking, some of the spectrums that we are going to see for different sampling frequencies. First, top one is nothing but the oversampled signal. That means sampling frequency is more greater than that the two times of the maximum frequency. That will not affect the signal recovery at the time of reconstruction. It will not affect the any anything, and no higher frequency is going to be added with the uh, original signal. Second one is perfect sample signal, Nyquist sampling signal. So second one, we clearly that we are clearly see that the sampling frequency is exactly equal to the two times of the maximum frequency signal. So in this scenario also, we are not encountering any type of aliasing effect. When you are going to see the sampling frequency lesser than the twice of the maximum frequency, that means under sampling signal we are going to see some aliasing effect, in the signal spectrum. It will causes the losing the information at the time of reconstruction the signal. So this is the main effect we are going to see in sampling frequency whenever the sampling signal, whenever we are going to take the sampling frequency less than that the twice of the maximum frequency. Now similar kind of analysis we are going to see for the two-dimensional sampling theorem also. We already know that the two-dimensional signals, and that means there is a two-dimensional spatial dimensions are there. One is x and y. This is a function of that means the image is an example for the two-dimensional signal. That means whenever we are going to see some band emitted signal is a function of x and y, that will be sampled according to the both the coordinates. So we need to discretizing the signal. We need to take the samples of the signals at the both the coordinates, that means x and y coordinates. So in what way we are going to take that samples is the matters here. Whenever the we are already know that the sampling rate in the images is the number of samples taken in the both the spatial directions, that means x and y directions, at what the unit distance. So that is what the sampling rate in the images. This sampling rate we are going to select greater than the twice of the maximum frequency in the maximum frequency of the u and v, frequencies of the maximum frequencies of the both the directions, that means x and y directions. If it is fails, if the we already know that if the condition set, if the two conditions, that Nyquist sampling frequency rate as well as the oversampling frequency rate, these two conditions are failed, then we are going to fall under the our undersampling case. This leads to aliasing that will corrupt the signal samples. That means we are going to lose the information of the image. That will not clear that we are not going to see the image clearly. That will leads the some of the high frequency components are going to be added within the signal. So this will leads the higher frequency addition of the signals. So these frequencies are nothing but the aliased frequencies. So we are already know that the sampling frequency is much greater than the two times of the maximum frequencies contained in the signal. So if you are not going to provide that condition, that is signal going to be corrected, that means aliasing will definitely going to be occurred. So once the this is the MATLAB result actually. So we see that the original signal is some of the some we clearly see that the clarity of the signal. So the left right side signal shrinking image, that means we are not clearly visible anything whenever we are going to see some of the edges at the image, in the image. So we are clearly see that the this shrinking image is affected with the aliasing. So original signal we are going to sample, so that sample signal going to be experiences the aliasing whenever we are not providing the sufficient sampling rate to the sampling at the time of sampling. So whenever we are going to experience these aliasing effect, the image going to be see some patterns called Moire patterns. The Moire patterns is nothing but the Moire patterns, vertical and horizontal lines we can see on the images. So these images, we this pattern is going to be affect the signal quality. The drastical decrease in the signal quality may occur due to the Moire patterns. So now we are going to see some of the remedies, that means anti-aliasing in the images. So in order to minimize the effect of the aliasing, that means the high frequency edges are providing at the sample signal, so that will be reduces by using the smoothing filter before in the sampling free, that will, before the sampling. Before the sampling, we are going to pass the original signal in the low pass filter or the smoothing filter. After that, we are going to pass the low pass output to the down sampler or some sampler, or whatever whatever the sampler we are used. Then it will not affect the signal, and we are clearly get the reconstructed signal, and the original signal may be reconstructed at the time of sampling going to be occurred. Now we are going to see some MATLAB results here. So here I am take the some image by using a command called imread. That image, I mean the colored image, I just converted into the grayscale image. After that, I just plot the original image. Now I'm going to shrink the image by using the resizing. That means we are going to resize in whatever in sampling. After the sampling, we are getting the resized image. That means we are going to get some low quality image after the resizing, when compared to the original image. This is the simple MATLAB code. Whenever where the sampling going to be affect the image quality, that means we are going to see result. This is the original image, and this is the uh, uh, we clearly see that this is the shrinking image. Just run it again. We see the difference. We just see the difference between the original image and the shrinking image. This is the original image, how it looks like, and this is the shrinking image. It's look like it's not that much clarity. We see that the horizontal and vertical strips that we more patterns will be appear at the image edges. The high frequency components may affect the signal. And we just clearly see that the original signal not having that edges, cleared edges, and there is a sharp edges, and original image is quite quality in nature, but We'll come to the this shrinking image. The quality of the image not that much compared to the original image. This is this is uh, this is how we can get the sampling frequency. So some this is the reference actually. This is the standard textbook, digital image processing by Woods and Ballage. So thank you.